Okay, good morning everyone. Today's an easy day. Today we'll look at doing things you have done often. Add, subtract, and multiply, but we'll be adding, subtracting, and multiplying polynomials. You have added and subtracted polynomials before, so a lot of this will not be new to you. So here we go. To add and subtract polynomials, you have to combine like terms. Okay, in like terms, they have to have the same power. So for example, 5x to the third and 2x squared are not like terms because the exponent is different. However, if I had 5x cubed and negative 7x cubed, they would be like terms, okay, because the exponent is the same. So with polynomials, like terms will have the same base or variable, x raised to the same power or number, or exponent I should say. Okay, so like terms will have the same exponent. So to add or subtract polynomials, you combine like terms. You can add or subtract horizontally or vertically. And I am just going to go over the, I'll go over the vertical method. Okay, one can certainly use a horizontal method, but I will go over the vertical method. To me, that organizes the terms of the polynomials much easier for students. I find students like being able to organize when they add, subtract, or multiply polynomials, and you'll see what I mean. But here we have two polynomials. We have a cubic trinomial, 2x cubed plus 9x, or 9 minus x. And then we have a cubic polynomial, 5x squared plus 4 plus 7x plus x to the third. So when we add vertically, we always want to put each polynomial in standard form. Okay, so how do we add vertically? Well, we take this polynomial 2x cubed plus 9 minus x, okay, and we'll write it as 2x cubed, but we'll write it in standard form. Okay, so we have 2x cubed. Now, I tell students that if you're missing a term, okay, include it, because you will see when we go do division that will be really, really important. So I like to emphasize that right away. Include the missing terms. And what do I mean by missing terms? Well, I see I have a 2x cubed for that polynomial. 2x cubed plus 9 minus x, but it don't have an x squared. And so I'll just make room for that x squared. I'll just use 0. So plus 0 x squared. Okay? And then minus x plus 9. And then the other polynomial I have here is 5x squared plus 4 plus 7x plus x cubed. And again, I'll write that in standard form. So I have x cubed plus 5x squared plus 7x plus 4. And then we just add. So 2x cubed plus x cubed is 3x cubed, and then 0x squared plus 5x squared is just 5x squared, and negative x plus 7x is 6x, and then 4 plus 9 is 13. But again, I do emphasize the point that if you're missing a term, include it, but just use 0. And that, again, will be so important when we do division of polynomials. And so we call that adding vertically. Here we're subtracting polynomials, but we'll just change subtraction into addition. We'll distribute the negative, okay? So here we have 3 minus 2x squared, and then we have minus x squared plus 6 minus x. Okay, so what I like to do, I am going to distribute the negative, okay, or add the opposite, and so I'll have a negative x squared, as you see down here, and a negative times a positive will give me a negative 6. They're writing this in standard form, I guess. Okay, well here they wrote it in standard form here. Okay, actually they did not, did they? Well, why would they write one in standard form and not the other? Well, okay, so they didn't write neither in standard form. All right, so, but nonetheless here, I guess they should have done this here. So minus 2x squared plus 3 and then minus x squared minus x plus 6. All right, now we'll go ahead and subtract. We'll distribute that negative. So a negative times a positive, that will give me a negative x squared, which is what you see there. A negative times a negative, that will give me a positive x. And then a negative times a positive, that will give me a negative 6. Okay. So everything is in standard form and the negative is distributed. Now we can just add. We can add vertically. So again, notice here I have a negative 2x squared, so I'll be working with this polynomial. I have a negative 2x squared. Ooh. And then, but I'm missing my x, but I'll just use 0x there. And then plus 3. And then for this polynomial here, then I just have a minus x squared, and then plus x, and minus 6, and I'll just add. So again, key point, always include every term you have. If you have to use 0, please do so. And so this will give me minus 3x squared plus x minus 3. Okay. So adding and subtracting. Subtracting is nothing more but adding the opposite. So that's adding and subtracting of polynomials. Again, not anything that you haven't done before. So again, I'll go over a couple more examples here. So I have this polynomial as a standard form. So this would be negative 36x squared plus 6x minus 11. And then I have that polynomial. And I have so again, oops, I guess I didn't have an x cubed, did I? So I better make room for an x cubed. So here, let me move that over, because I see I have an x cubed here, but I don't have an x cubed in the other one. So I better make room for that. So 0x cubed minus 36x squared plus 6x minus 11. And then for the other one, I see I have a 16x cubed plus 6x squared. And I don't have an x there, so 0x, and then minus 5. Okay, so there. So again, notice I made room for those terms I didn't have in each polynomial. And so I just add. So now I have 16x cubed minus 30x squared plus 6x minus 16. Done. Another one. So again, here we're subtracting, so I'm going to add the opposite. I need to distribute that negative. And so this is going to be plus. That would be a negative 15x squared, a negative 3x, and a positive 2. Now let's see here, the largest exponent I have is 3, so I'll work with this polynomial first. So that will be 5x cubed plus 6x squared. I'm writing things in standard form. I don't have anything for x. And then I have 12. And then I have, let's see here, the other polynomial. I don't have any x cubed, so I'll just write 0x cubed. And then minus 15x squared. And then minus 3x. And then plus 2. And you add. And so now you have 5x cubed minus 9x squared minus 3x plus 14. Done. Okay, so as you see, adding and subtracting polynomials is pretty easy. But remember, the key here is to combine like terms. You can't add an x cubed and an x squared. You certainly couldn't go 5x cubed plus 6x squared as 11. Okay, 11 what? I don't, no, they're not like terms. Have to have the same variable raised to the same exponent. All right, key point. Now, we'll look at multiplying polynomials. There's like 3 different ways you can do this, okay? And I think the last way I'll show you is the way that I see a lot of students do it. Okay, so to multiply any 2 polynomials, you use the distributive property and then multiply each term in the second polynomial by each term in the first polynomial. Okay, and if you want to do this approach here, I would always say have the polynomial with the greatest number of terms on the right, and then the polynomial with the least number of terms on the left. All right, so here, so all we need to do is distribute. So if I have x times x, that will give me x cubed. So again, I'm distributing. X times x squared will give me x cubed. And then x times a 4x, that will give me 4x squared. And then x times minus 3, that will give me a minus 3x. And now I have to distribute that positive 2. So 2 times x squared, that will give me 2x squared. And then 2 times 4x, that will give me 8x. And then 2 times negative 3, that will give me a negative 6. And then we combine our like terms. Okay, so let's see here. I have an x cubed. So I'll have x cubed. And then let me look at my x squares. I have a 4x squared and a 2x squared, so that's going to give me 6x squared. And then I have a negative 3x and a 8x, and that will give me 5x. So that will give me 5x. And then finally minus 6. Okay, so there. That's one way you can do it. It says keep in mind that if one polynomial term has m terms and the other has n terms, then the product has m times n terms before you combine like terms or before simplify. So I had 3 times 2. I should have had 6 terms, and I did before combining like terms. So that's one way you can multiply polynomials using the distributive property. The other way you can multiply polynomials is called using the vertical method. And the vertical method is something you may remember way back from middle school. So what I mean by the vertical method, well, I'll just give you an example. So let's say here I have 2, 4, 5, 3, and I'm going to multiply that by 12. So let's recall how you would do that. You're multiplying. So you go 2 times 3 is 6. 5 times 2 is 10, carry the 1. 4 times 2 is 8, carry the 1 is 9, and 2 times 2 is 4. And then you go 1 times 3, and then 1 times 5, 1 times 4, and then 1 times 2, and then you'd add, and you'd get 6, 3, 14, 8, 9, and 2. So the vertical method. So, but this will be with polynomials. So I'll work with the same polynomial I had here. Okay, and again, when I do this, when you use the vertical method, you want the polynomial with the greatest number of terms. So I have x squared plus 4x minus 3. You want that to be at top. So this would be x squared plus 4x minus 3. And then the other polynomial, x plus 2. And now you just multiply. Vertical method, 2 times negative 3 is negative 6. 4x times 2 will give me a positive 8x. And then 2 times x squared will give me 2x squared. And then x times negative 3, that will give me minus negative 3x. And then x times 4x, that will give me a positive 4x squared. And then x times x squared, that will give me x cubed. And then you add. And you'll get x cubed plus 6x squared plus 5x minus 6, which is exactly what we got before. So that's exactly what we got before. So we call that the vertical method. The vertical method of multiplying. Okay? It's like the vertical method of adding or subtracting, except we're just multiplying. Vertical method. Now the other method that still is like probably as much as a vertical method is what I call the box method. Okay, so here I'm going to rewrite the polynomial. So what did I have? I had x plus 2. I had x plus 2, and I was multiplying that by x squared plus 4x minus 3. Now the box method here is that you have to make a box that's a perfect square. Okay, the sides of each square has to have the same number, the largest number of terms for a given polynomial. So when I take a look at this, x plus 2 is 2 terms, but x squared plus 4x minus 3 is 3 terms. But the more important thing is that this polynomial here, it has every term for x. It has x squared, it has the x squared, it has the x to the first, and it has the x to the 0. So that means I'm going to make a 3 by 3 box. If I had something like this, if I had something like 5x to the 4th plus 2x minus 1, I would have to account for x to the 4th, x to the 3rd, x to the 2nd, and then the x and x to the 0. So I would have a 5 by 5 box. Okay, I'd have to account for every term. X to the 4th, x cubed, x squared, x to the 1st, and x to 0. I'd have a 5 by 5 box. Here, I'm going to have a 3 by 3 box. I need to account for every term. And then this is 3x raised to 0. So here we go. So we make a 3 by 3 box. Okay, and then we just multiply. So, and students like this a lot because it helps organize things. So here for this polynomial, I'll just work with the one I highlighted there in green first. So I'll make that the top one. So this would be x squared, this would be 4x, and that would be minus 3. And now notice here for this polynomial, I'm missing the x squared, but like before, we'll just use 0. Okay, so I'll write that 0x squared, but then x and then 2. Okay, and then we just multiply. So 0, so all of this row is going to be 0. 0 times anything is 0. X times x squared would be x cubed. X times 4x would be 4x squared. And then x times negative 3 will be negative 3x. And then 2 times x squared will be 2x squared. And 2 times 4x will be 8x. And then 2 times negative 3 will be negative 6. In the way you read this, you read things on the diagonal now. You add along the diagonals. So I don't have, okay, so as I add along the diagonals, that will give me x cubed, and then plus 6x squared, plus 5x, minus 6. Okay, and it's the same thing that I got before, so this is the third method. So if you notice here, I got x cubed plus 5x squared plus 5x minus 6, x cubed plus, or 6x squared plus 5x minus 6. Let me just, yep, x cubed 6x squared 5x minus 6, x cubed 6x squared 5x minus 6. That's the box method. This is the vertical method. And then that was just distributive method. See, 3 different ways you can do it. Whichever one you like the most, go for it. And then one more example. So here, they're just using the vertical method. I'm not going to do the distributive method, but you certainly could. But again, notice here that you write everything in standard form. And in a minus 3. Okay, and then, yeah, you multiply. Now the box method again, okay, I would have a 3 by 3 box because I have an a squared and a to the first and a to the 0. So I would have a 3 by 3 box. So let me do that. In this method, again, like I said, students really like the box method, and I can see why. It helps to organize everything. So here I have a squared, and then negative 5a, and then 2. And then I don't have any a squared, so for the a minus 3, but I have an a and a negative 3. And we just multiply, all of this will be 0. This would be a to the third. A times negative 5a is minus 5a squared. And this would be 2a. And this would be minus 3a squared. And then plus 15a. And then minus 6. Okay, seems like let me say a minus 3. So a minus 5a squared and 2a. Yep, okay, and then we add on the diagonals. So we add on the diagonals here. And what do we get? We get a cubed minus 8a squared plus 17a minus 6, which is the same thing you got there. So the box method versus the vertical method. Do whichever one you feel more comfortable with, whatever floats your boat, rocks your world. Okay, so whatever works for you. All right, so that's it. So what did we learn today? We learned how to multiply polynomials using 3 different methods: the box method, the vertical method, or the distributive method, and then adding and subtracting. It's a pretty easy lesson today.